Good evening, everyone. Welcome to CoffeeJUG Online. Today, I'm excited to introduce you our new speaker, Piotr. By the way, it's our second speaker on CoffeeJUG, so congratulations to him. As usual, warm welcome to everyone. Don't forget to support Ukrainian armed forces. Remember that even small contribution can make a huge difference into this war. In Community We Trust, we have organized more than 50 unique events with 700 unique participants on it. And remember that your personal involvement made all of this possible. Thank you to our organizers team, Igor, Olesa, and Oleg. Your hard work behind the scenes makes all these events possible. And join us in our social medias, Facebook, Twitter, and Telegram. Piotr, wish you good talk. You guys enjoy your time and see you later.
Hello. Welcome to my talk called Hunting with Stream Gatherers. As introduced, I'm Piotr Przybyl. I speak to you from Poland, from Wrocław, and this is briefly about myself. So I work as a senior developer advocate for Elastic. If you need to find me on social media, this is where you can find me. Also, I am on LinkedIn and a few other places. Personally, I'm also Java champion and test containers community champion. And whenever I have something I think important to share with the community, with all of you folks in written, I do this using my personal blog page called softwaregarden.dev. And before we really start, I mean, there is an option. I know you have an option to put your comments. So I'd like to know for the first thing, what Java version do you use in production, right? So not that what's your like source version of the code you're using, but what's actually the version of the JDK you have installed in production. So feel free to type it into the chat. And because we have like a little delay, allow me to talk a little bit about this topic. I've heard many times that Java 8 is so good that you don't have to go any further, right? And it's perfectly capable of doing this, whatever we need, right? So everything else that happened after is just like some like magic or mambo jumbo. That's not really the case. So as I work for Elastic, right, you might have heard that there are like a few things developed by elasticians, and one of them is, of course, the thing that started it all, which is Elasticsearch, right? So I wanted to show you something. So right now, so what I did basically is like, Docker PS. I'm running locally Elasticsearch, right? See, this is the 8.17.2 version, right? And then if you go inside this container, right, what I can do, not everything. Let's see what Java version is it running. And as you can see, it's the latest version, because right now the version that's supported is OpenJDK 23. So if you want to answer this question, like what Java version I'm running in production, and you're using the latest Elasticsearch in a Docker container, at least using one of the official containers, then you're running the latest supported OpenJDK, right, without maybe even knowing it. So I just wanted to bring it to your attention that it's not just, even because it's not an LTS version, still it gives us a lot of value. So today I'll be talking about stream gatherers, but there are more, of course. And just to give you like a little bit of taste, why is it important to go for the latest Java version, right? Even if it's not an LTS, unless you have a valid support contract, of course, right, with one of the vendors. You see, one of the reasons it's done is first, where is it? We should see somewhere in here. I mean, the line is quite long, that it's using the G1 collector by default, of course. Oh, here it is, right? So you may say, yeah, but I'm able to use G1 in Java 8 or Java 11 as well. Well, fun fact, it's the same name, but not necessarily the same collector, right? So even if you still compile your source code against Java 8, right, and you have the jars or class files compatible with Java 8, if you deploy them on the newest JDK, then you get all the performance improvements, right, that come along with the version. So as you can see, this G1 version is probably better at handling your load than the workload than the version, the older version you're using. The other thing that you might not see initially is this. So under the hood, Elasticsearch is using the Vector API, which is an incubator module. Okay. And why does it do it? Because then it allows us to go much, much faster for certain queries, or especially for this language called the SQL. So basically, it will then use the like a native API when calling proper stuff from the CPU, right? So relying on modern CPU architectures automagically, right? So see, if you are saying like, I'm sorry, really sorry for you, Julia, that I allowed myself to say stuck with Java 8, right? Because you're not allowed to use these goodies or like modern garbage collectors like ZGC, Shenandoah, and so on. So as you can see, it's not like a fancy schmancy business. It's actually like you can have like a proper product, right? And you can still be using the latest non-LTS version, right? And let me just go back to slides. So if you are just curious how I did that, sorry, a little ad, you can go here, right? Go for on GitHub, go for start local, and then you're able to start your Elasticsearch in Kibana. And I'll be using it for like one of the demos later on. But now let's talk about the stream gatherers, what they are. A little warning. I try my best to give you folks accurate information and so on, but sometimes I'm just a human being, right? It's a human thing to make mistakes if they're not malicious, right? So I reserve myself this right. Also, like, as we all painfully know, don't trust talking heads on the internet. Verify everything you read or hear or so on, right? So it's actually like spreading misinformation is actual thing, right? But back to the agenda. So what I'm going to do tonight is basically this. So this is the plan for the game. We'll start with a little prologue, then I'll go through 3 parts: the why, the what, and the how, and we'll finish with like a little epilogue. And I also plan to ask as many questions as I can. So if you happen to have any questions along the way when I'm talking, please use the comments as well, and type them, right. So we'll be handling them at the end of the session. So the prologue. Do you know what happened 3,971 days ago? You might know, you may not know it. It's not that very much important to know this date, but what actually happened back then was that Java 8 was released, right? So almost 4,000 days ago. We are short of like about a month. So what happened is that, among many other things that Java 8 introduced, one of the key changes or key additions it introduced was lambdas, right? Or lambda calculus was brought to Java, lambda expressions, right? And it themselves are very useful because now we can just use lambdas instead of anonymous classes, right? With just these few methods or overridden, or this one method overridden. But for streams, they are one of the key components. I mean, imagine using streams in Java without lambdas. That would be really, really problematic. So lambdas, instead of being just a thing on their own, right, they also are a key enabler for the streams. And a quick recap for those of us who are not using streams, or maybe that we have people like from other ecosystems, not necessarily Java. So let me let me briefly introduce or reintroduce what a stream is. So basically, a stream consists of three things. Sorry. First, there is a source, right? There's a collection. There can be a split iterator or like a generator, like we can go for like a random int or something like this. Then we have any number of intermediate operations, be that filter, map, flatMap, and so on. And we also have a terminal operation, just a single terminal operation when we turn a stream into something. Because what a stream is, it's basically a declarative receipt how to turn some data into some other data, right? So instead of going in with like for loops or any other kind of loops, what we can do, we can just write a stream. So from this thing, the source, I want to do this, this, and this, and at the end, I want to have this thing as a result, right? So let's say a list, a set, a string, a map, something like this, or like any other kind of object, actually. So these are the intermediate operations that were introduced in Java 8. I'm not sure I have listed all of them, right? So there are these few obvious ones, right, which we use, of course, which is filter, right? We want to get rid of certain elements we don't like. There's like a map, so we can change, for example, even the type of the object. We can call distinct. That's very nice if you want to have like avoid repetitions, and distinct relies on the equals method, right? That's maybe important. Of course, we have flatMap, which maybe should have been called map then flatten, but that's another story. We have, of course, sorted, limits, keep boxed, parallel is nice if you can afford running parallel streams, right? We'll get back to that. And of course, there's also peak. And I really, really hope nobody here is using peak for anything else than debug, right? So what peak basically allows you is to get like in your hands the object that is being processed at this very stage in the stream, right? And I really, really hope it's only used for like logging if you really need to debug, not for any side effect operations or something like this. And it's also important, sorry, maybe I have forgotten to say this, that there's a difference between the streams in Java, right, and the reactive streams, because reactive streams are push based. So we receive events, we receive basically something, and that's why we have to like control this flow of this information, of this data, right? So we have like some like rate limiting or flow control or whatever it's called, whatever business term you want to use. Whereas the streams in Java are pool based, right? So if we create this stream, nothing happens until we call a terminal operation, right? We can construct or almost construct the stream, and until we call this, for example, to list or collect or reduce, nothing happens. And here are these terminal operations. So as you can see, we can have I hope you're not using for each, right? So we have collect, reduce, min, max, count, if any match or all match, if we can find a first or any element, right? And in theory, we could go with just one of them, like for example, reduce, right? So using reduce, we could virtually implement everything else, right? But these are like very convenient methods. So we have them in this, let's say, stream API zoo. And there were more intermediate operations, right? So the story continued. So in Java 9, we had take while and drop while. So as long as a predicate was met, then we were taking or dropping some elements. In Java 16, we also seen this map multi with some primitive variants, right? And then there were also like some terminal operations. So with Java 16, after maybe not very heated, but a bit heated debate, we finally saw the toList method. So we don't have to call collect to list or to unmodifiable list. We can now just go for toList. But actually, there were more terminal operations or like ways to terminate your stream added through the versions of Java. So in Java 9, we saw collectors filtering or collectors flat mapping, right? So when we call collect, we have to supply it with a collector. So we saw like more ways of doing this. In Java 12, we saw collectors teeing. This works basically like a tee command in Linux. So if we have two collectors, we can tee them together, meaning that both of them will receive exactly the same element, which means that we can call the terminal operation just once, but it will be feeding the elements to both team collectors. And of course, we can like mimic this way binary tree. So if you want to have like 3 or 4 or even more collectors, it's doable. So the benefit is we do it, we collect the elements in all of these collectors that I teed in just one pass, right? Because the streams, of course, aren't reusable in Java. And also there were in ecosystem, there were like libraries. There's, for example, Polar collectors from Grzegorz Piwowarek and his friends, right? So you can provide your own thread pool, even virtual threads, as far as I can tell, in recent Java versions, and so on. And of course, we had like our own collectors, right? In the utils class or tools class or whatever. Like, don't lie to me. I know you have them hidden somewhere in your Git repository, right? There's like any decent project, any old enough project has this tools or utils class. It's always there. It's freaking guaranteed, unfortunately. So let's just go to the first part. After we like figure out what's the current state of affairs when it comes to streams in Java. So let's go to the part one, the why. Why are we in need of these stream gatherers, right? Or better said, what are actually the problems that we currently facing with streams in Java? So to show you like what I mean, I'll be using this stream. So this is like a countdown, count out in Polish from Krakow region, I was told. So let's say there's like a group of children and you need to like figure out that, for example, who's going to be the first one in hide and seek or something. So like you count out the winner, right? So it goes like this, like ene, due, rike, fake, and so on. And this is basically like a collection or a list of words. So I'll be splitting these words by space, right? So these will be my elements that I will be processing, right? In this little demo. And now the question is, or let's say there is a business requirement that came from us from like another department, right? Let's say that we need to get one word by length from this count out. So let's say and it doesn't really matter what kind of word that is. It just has to be one if there are any words of that length. Maybe just to give you an example, we're going to select. Oh, there's only one word with. Let's say it's a word with length 1, so it's going to be I. Then we don't have any words representing the length 2, but then for the length 3, we can select either ene or due or eus, right? So any of these 3 will work. So we are happy to just receive one of these 3 words representing the length of 3, and so on for 4, and so on and so on, right? So how can we do that using current stream API? Let's say we want to stick to stream API. So we can go for something like this. Maybe I can switch to IntelliJ, right? So it should be the same example. Right, only this time you see I'm not cheating, right? So let me run this little demo actually. Come on, run. Okay, yes, it did run. Okay, cool. See, so this is the result, and the order doesn't matter, right? So we got we got ene, rike, and so on and so on with, using collectors. So how does it work, right? So we have this stream, and then I can go for collect method, and I can create my own collector, right? So I go and use collecting, and I use to map collector. So this is going to be the key mapper, right? Because I'm going to create a map as an intermediate operation or accumulator. Better said, right? So the map is going to be keyed by the length of the word. Then the value mapper would be basically the same. So it's like identity word to word, and then merge function. So if this was running in a way that I already have a word of that length, or what I selected to, or I chose to do here, if I have an existing word and a new word, I just keep the existing one, right? So this is basically acting like a first in, first out. And by the way, this single underscore it can be used, I've forgotten, since Java 21 or 22 as a value that you want to ignore in your Java code, right? So it got deprecated in Java 9, and now it is reintroduced, right? And it basically means ignore, right? So if you want to read more about this, look for the record patterns gem, right? And then after I collected like this, I want to go for this and then part. So what I want to do is I want to return a hash set, because I'm only interested in the values, right, of that I have collected so far. And this is the code I have. So now, and this is of course like printing it. Now the question we have to answer ourselves is, okay, I explained to you the requirement or the business need, right? We went through the code, but would you be really able to figure out, just by looking at this code, what is the problem that this code is solving, or what's the business requirement is satisfying? And that is the thing, right? And even if you go for something like perhaps a bit more like you know, organized, so I can go and create this unique length collector, right? Because collectors can also be basically objects, right? See, so I'm creating an object, right? And it's doing the same. Maybe it's even better to see here that I have this parts, right? So it's supplier, accumulator, and combiner. So I supply it with the initial state. I'm adding a word if it's absent by this length, and so on, right? So this is another way of doing this. But is it like a better way? I'm not sure, right? But this is it should give us the same result. I mean, depending of like the order here and so on, right? So it's solving the same thing, only like what we did, instead of creating this thing in place, we basically introduce an object of collector, right? So this is our collector, as you can see, with this somewhat convoluted API, right? And this is the result we get, which is the same. However, let's say that we have another requirement coming. Yeah, if we need to reuse it, we can just go and create this collector, right? But what happens if there's another requirement coming? Hopefully not in the same sprint, but in the next sprint, right? As it should be. So now they said, okay, very nice, you solved this, but now we need to lowercase all these words, because if you remember, the NA was uppercase, or the first it was capitalized, right? The first character was an uppercase, right? So now the new requirement from the business people or product owner or whoever, or the client, is now we need to lowercase all these the characters, right? So we can end up with something like this. So let me go and choose this version, right? It should work as well. Well, not quite, because instead of going all lowercase, we misread the requirements, so now it's all uppercase. But like, whatever, let's pretend it's implemented correctly. Wink, wink. But let's see the code, right? So as you can see, I'm using the same collector that we introduced in the previous requirement, right? But now what I have to do is I have to go again, like collecting, and then I had this result. This was a set, right? A hash set. And now what we need to do is to create another stream of this. So this was a stream. Now it's right, this was stream, this is another stream, and now I'm going to map these, right? And then I'm going to collect them as set. And as you can see, the result is more or less as expected. But do you really can you really say that this is an efficient code, right? And this is the problem, right? So it's meeting its functional requirements, but it's, I mean, even without running benchmarks and stuff, like, we can tell that this is I mean, for critical path, if this was like a core requirement of a system, that's basically a no, right? We can't go this way. But you can tell me, yeah, you can do it some other way, right? So maybe we can map all the elements in advance, right? Like, extend this previous example just by going map. It's doing too much, right? Because we just need one word of length 3. So why do we need to uppercase or lowercase all 3 of them? right? What if there are thousands? We are wasting CPU cycles, right? We're wasting money. We are generating CO2 and whatnot, right? And basically, it's going to take too long. So this is not an approach. Or maybe we can go for like a for loop approach or something. But yes, then would it be really easier to understand what the code is doing? Not really. Or maybe we can decorate all the elements. So since, I mean, I've seen quite a few saying it's Java 17. We could go for records, wrap each string in a record, right? Each string, and then what we could do is override the equals method. So when we have two records wrapping strings of the same length, they would produce true from their equals, right? So we can use the distinct method that's already existing in stream, right? But then it's not really. We're not really sure if it's the dog controlling the tail or the tail controlling the dog. Okay, or we can have another pro and fancy solution, right? With, I don't know, some loops and go tos and whatnot. Or what we could do is like we could open OpenJDK tracker, right? And we could do like create a ticket and say, please add this stream distinct by method. So here we could add like a lambda. So unlike this method, which is always using equals, we could use some other ways of selecting if elements processed by the stream are distinct or not, right? The thing is, they could have added this method just to satisfy a small fraction of Java user base, right? I mean, this could still well be like thousands of people because Java is still used by thousands of people. So even 1% could easily generate like a big numbers. But then the API would be really more bloated, more verbose, more difficult to maintain, and so on and so on. And trust me, it's not only about distinct by method. There are dozens of things that could have been added like this because someone has a super special need for a new intermediate operation when it comes to Stream API, right? When you have new terminal operation, it's not that big kind of problem because you just implement your own collector as we did, right? But for intermediate operation, it's problematic. So now the thing, this is it. If only there was something that we could use just as we use collectors, right? We don't have this issue with collectors because you just implement your own collector. So can we have pretty please the same approach for intermediate operations in streams? And here we go to part two, the what, right? So what has been done to Java? So I guess you're familiar with the concept of plugin, right? This is maybe even like a design part. So there's like add-on or plugin. So basically you create a piece of software, and as long as it obeys the API, it can be used in some place to just do something, right? So here they are, stream gatherers, which were a preview feature in Java 22, which are still a preview feature in Java 23, and which will become a standard feature in Java 24. As far as I can tell, there were no difference between these versions, right? So they all behave the same way. So today I'm using Java 23 because it's still the version that is like supported, or that's GA. But if you read this code, you should be able to use it in Java 24 as well without this -- enable - preview flag for your compiler and Java, right? So these are the times of the AI, they say, right? Or the emerging AI or advent of AI. So I ask AI, hey there, AI, can you tell me what are stream gatherers in Java, right? This was the question I was asking, and I got the answer. Stream gatherers in Java refer to, and this is the answer, right? So as you can see, it's using collectors. So I have some other talk, right, describing like how to avoid problems like this, how to make sure your API doesn't hallucinate, at least that much, right? But this is it. So I don't know how it works in Ukrainian if you translate your stuff, but for Polish, of course, it's just like with English. to gather and to collect are semantically quite close to each other, right? So it's not so difficult when it comes to making your AI hallucinate. So I will try to give you the proper answer without hallucinations. So basically, it's this. We have a stream, right? And then when we have a stream, we can call gather method, right? Any number of times, in fact, right? And then we go just, for example, collect or reduce or min, whatever we can. No, not min. Sorry, because this doesn't work with primitives objects, right? But collect, reduce, they were all working okay. Right. Or if you're more like a functional fanboy, functional style, you can go for gather and then another gatherer and then another gatherer. And so the story goes, right? So we can toss them more gatherers. And the nice part is that with having just this method, we could implement any other kind of method like min, filter, flatMap, and so on. So of course, I don't expect them to be removed anytime, right? They are needed and they are very convenient methods. And they directly tell you the intent of the person that wrote the code or the requirement, right? That's also important. But for the other cases that aren't covered in the Stream API, we are able now to call the gather method, right? So what these Stream gatherers can do, they can transform elements, right? So they can go like map, they can transform every element into another element, or they can take one element and generate you a number of other elements, or they can take any number of elements, right, and just turn it into one element. So if you take this, it basically looks like that you can take any m number of elements and turn it into n number of elements. And there are some cases when it's really convenient or useful, right? It can track elements that were already processed, right? It can sort of suspend the elements. So you can be gathering elements, like any number of elements, and then once you figure out, okay, I have enough, let's say for some kind of like batch processing or something, you just push them downstream in one go, right? Or for paging, something like this. They can also short circuit, meaning that they can turn infinite streams into finite streams. And of course, they can also keep state between executions if you use them as objects, pretty much like every other object, right? They can keep the state. And they also enable parallel execution. And now we jump for the part 3, which is the how to use these stream gatherers. So let's try again to satisfy the requirement, the initial requirement we had on the second version. So we want to have unique words by length, each length represented just by one representative, and it should be uppercase or lowercase, right? So this is it. So it can be done like this. We can have our stream, right? We can gather these elements and go unique by length gatherer, and then we can map them uppercase to or lowercase. I mean, they were only the ones that were that we've seen, right? And then we just collect them, let's say, to unmodifiable set. Or we can go okay, so and this is the gatherer, but let me go for the code. I mean, the code should be better. By the way, you can find the code online, right? So you don't need to take screenshots. It's already there waiting for you. Okay, so let me rerun this code and let's see. Yeah, see, I mean, we're just testing it manually. It's not the best way, right? Automated tests are, of course, better. But as you can see, the results are as they should be. So this is it, right? We have the stream, the gatherer, this mapping function, and we're collecting the elements, right? And now I'm going to ask you this question, and you have to answer it yourself. Isn't it now more obvious what this code is doing than the previous version? And maybe it's not totally obvious because I'm not the best when it comes to giving names, right, to things. So maybe this gatherer should be named differently. Anyway, even with this approach, right, it tells us more or less what it's doing. So let me go here and run the last version without going up for now. and let's see how it works, what it's doing. So to create this gatherer, right, I can use this handy helper method, which is of sequential. That means that I'm going to process the elements sequentially, and I provide it with accumulator, which is going to be a hash set, and an integrator. Integrator is like an engine. We'll get to that. And basically, this integrator takes three things: current state, the element I'm processing, and the downstream, which is the way for me to push elements like further down the stream. Right. So I just check if my state contains the length of this element, because this is a set of integers, right? So I'm not even keeping the elements in themselves. I'm just keeping the length of the elements that I already pushed downwards, right? So if, let's say, I'm processing n, so I'm checking if my state is empty, right? Doesn't contain 3. So I'm adding to my state 3, just the number 3, right? And I push n downstream, right? And then is the next element is due, right? So then I check, oh, I already have due, right? So I'm just skipping this if, and I return true, and true means give me more, right? If I return false, it means I'm done with processing the elements, right? So this is how it works, right? So yeah, we can also see it or do it like this, right, with this integrator. I've just shown you this, and this is it. This is the same code. As you can see, maybe it's even less complicated, and yeah, it's producing in one. That's important, right? I'm avoiding unneeded work as much as possible, because I'm here gathering only the elements that can be pushed down to the very result, right, of this thing, which is, let's say in our case it's a set, and I'm just manipulating on these elements, right? So if I change the order of these, I will still get, of course, the same result, but I will need to spend more time and more CPU cycles, because I'll be mapping every element, right? And I really hope that this API makes the intent of this code more obvious than this convoluted collect and then awesome wrappers to go for distinct by, and so on and so on. So here it is, the formal definition of gatherer, and I don't like it because of this T and A and R. And I think Java is already quite verbose language, some say. So I don't think we should be short of letters, right, to use as generics. So I prefer this definition. So as you can see, gatherer depends on 3 types: the type of element it absorbs, right, or consumes, the type of elements it emits, and the type of the internal state it's skipping, right? And gatherer consists of or may consist on 4 things, but this thing is mandatory. So you always have to provide an integrator. Integrator is kind of like an engine of a gatherer. It's basically, as we've seen in previous example, telling us what to do when an element is consumed, right? And then we can also have initializer to initialize our state. We can have combiner that's needed, for example, if we're running a parallel operation and we need to combine or like merge two gatherers together. And there's also a finisher that's like also optional code that you can call when you think you're finished processing your data. I'll show in a minute when it can be useful. So they can also be constructed on site, as we've seen, right? There is like, we don't need to create a class implementing gatherer. So we can go like this, having just integrator, we can go for our sequential. We can add finisher or initializer, right? Or 3 of them. And of course, here we use integrator and finisher, and here combiner and finisher, because this is not sequential, this can be parallel, right? So combiner is needed. And let's go quickly through these parts. Integrator is like this, right? So it has the current state, the next element, or the element I'm processing right now, and a way for me to push it, to push something downstream. not it, but something, right? So it consumes this next element, can inspect and update current state, and of course can send any number of elements downstream. And if it returns true because it's of type Boolean, then it means give me more. I want to process more, right? There's also a greedy integrator, which is basically an optimization that says that it will never short circuit, right? So it will always return true. So then we don't need to check for this result. There's a combiner that can combine two parallelizable gatherers. Sorry, English is not my mother tongue. And there's a finisher which can still operate on downstream. So which means finisher can decide if more elements can be put or pushed downstream. And there's this downstream, of course, this basically it acts as a sink, right? We can push elements down the stream as the name suggests. And there are 5 built-in gatherers. As far as I can tell. So there's gatherers fold, scan, window fixed, window sliding, and map concurrent. Let me maybe show you them in the code. Here they are. So yes, let me run this thing and make it a little bit bigger for you. So as you can see here for fold and scan, I'm using exactly the same function. It even got highlighted nicely here, right? But the results are different. Here are the results of this. So folding, it's like in functional programming. Basically, I have like some elements. So in this case, I'm processing integers right from 0 to 9, and I'm folding them like together. That's why in the end, I receive just one element, right? As you can see, one element, and it's all these elements folded together. And here, as you can see, I simply concatenated them, right? So this is the way I decided to fold them, right? And yeah, so my initial, so this is like the initializer for the state. So initially I have an empty string, and then to my string, I'm adding like a current number. That's why you see a single element being all these digits together. Then I can have scan, which acts sort of like prefix, I would say, if I were to rename it. As you can see, for the first element, again, there's nothing, but I track what I had in my previous processing. So that was 0. So I added it to my to the current element, which was 1. Then to 0, 1, I added 2, and so on and so on. So as you can see, it was like this growing thing. Then we have 2 gatherers which work on windows, right? These, I mean, maybe you faced this problem of windowing, especially in like SQL databases, right? So we need to create a window, for example, to process like a given number of records together somehow, something like this. So we can have window fixed or window sliding, and so when I have this these elements, I have window fixed, I have like 3 elements, then 3 elements, then 3 elements, and then I'm just left with 1 element. That's why we see 9 here. Or we can have this sliding window. So I grab the first 3 elements, then I'm sliding by 1, so I have next 3 elements, but this is like the, you know, between 2 and 4, and so on till the very end. That's why I always get a list of 3 elements. As you can see here, this stream because of window fixed or sliding will give me a list. So this will be a list of 3 or up to 3 elements, right? Like in this example. Okay, back to the slides. I'm very happy that you folks are asking questions. We'll try to answer them, but let me first go through the slides at code demos I have prepared, okay? Because I think some of the questions will get answered along the way. Okay, so yes, these are the built-in gatherers, and now time for epilogue. And this is the issue. If only we could use streams efficiently more often, right? So if we have like single-threaded streams, it's not a big problem, right? The JIT would do a nice job, and so on and so on. So this is not such a pain. It's, however, somewhat more problematic if we want to do more elements in the same time. So if we want to go for parallel streams, right? And we can't really use them, especially in critical parts of our system, because they do block. And I should have an example here just to tell you or show you, yes, this concurrent mapping. What I mean by this, let's say, so what I'm going to do here is I'm going to process 100 elements, right? And let's say these are like invoices. So I have 100 invoices, and here I just mimic it with like slow to double, which is, let's be honest, it's cheating. It's demo code, right? Never ever please call thread sleep in production code. Even in test code, you can go for something better, like you can use a utility or something. So this is demo only. Okay, let me maybe add this like demo only, please, right? 11. Never run this code in production, okay? And it's also not a proper benchmark. It's just to illustrate another problem we might be facing, right? So basically, I'm sending an int here, right? And after a second, I will get the thing doubled, right? I will get like twice as much, basically. So let's go back to this example. Let's say I have 100 invoices, and now I need to call my, let's say, payment system to check if these invoices were paid. Right, and then I go for each of these invoices. I need to do like a network round trip because, for example, there's no batch API or something. I can just check for one invoice number for the payment data, right? And I either receive something or there's null, right, or nil or whatever you call it. It's just, let's say this round trip takes 1 second because the other system is slow or something like this, right? So when we call something like this, when we generate the report, I can also like give you now a little hint. Sorry, not here, but in here. Right, you can see basically the computer I'm running. So as you can see, it has 12 logical cores, right? Which means if it's not like if they're not competing, I can run up to 12 threads concurrently, right? I mean, context switching and so on, but let's not get too deeply into this. So now if I run this code, right, how long will it take to run it? So maybe let me just run it and I will explain the result. Okay, so that's why we're avoiding parallel streams in general. I even added some debug, right? Maybe I should have removed this debug. Let me actually remove it because it's influencing the way we see things, right? Yes, but or maybe not. Now but you were able to see that it did it in batches, right? Like 12 elements, 12 elements, 12 elements, and because of this, the whole process. Oops, this time, I mean, the computer went busy. I mean, ideally, if I'm not like streaming and my CPU power goes entirely into this, it goes for like 9 seconds, just like the previous run, I believe. Because if you divide 100 by 12, you get 8 1/3, right? So that means 8 seconds all cores are busy. And then for the last remaining second, for the last 4 elements, we have also CPU bound to this, and we can't divide it or distribute it between cores. That's why it's at least 9 seconds, right? Why is this? Because this parallel streams is using ForkJoin pool, and these are like regular threads and they are blocking. So even if you don't do nothing, even if they don't do anything, then we are just wasting our time here, right? The CPU is not read and so on. That's why we don't use this if there are like any network round trips and so on. And even if I like wanted to go and let's say double the throughput of my system and just copy this method, right, and run it twice at the same time concurrently, it wouldn't double the throughput because, fun fact, all parallel streams are exhausting the same ForkJoin pool, right? So if one, let's say, if I use that in my REST and one of my REST endpoints and someone called this, I mean, good luck with the performance of the rest of the system, right? Or everything is like used here. So that's why we have this problem, right? And now the thing is, if only there was something in modern Java that would allow us to do some IO operations without like wasting our CPU cycles, right? So this thing will take, at least on my computer, at least 9 seconds. This, if we can't double throughput like this, right? So it will add at least more 9 seconds, and so on and so on. And there is this true gem of Stream Gatherers API. I was like so positively surprised by this that I even wrote an article about this. Right, you can see it on my blog page, right? And it's this built-in gatherer called Map Concurrent. I think this is really underrepresented piece of the API. It's mentioned just once in the whole JEP, and I even annoyed the author of the JEP, Victor Klank, that I'm not happy that this thing is mentioned only once, because I think it's a really nice thing. And let me show you what I think it's really nice thing, right? What I need to do is this, right? Instead of going for parallel and map calls, what I'm going here is I'm going to call gather. And as you can see, I'm calling gatherers map concurrent, and I just use factor 100, which means I'm willing to process up to 100 elements at the same time, right? Or let me disclose it a little bit. I'm able to start up to 100 virtual threads at the same time, right? And then it's exactly the same method, right? It's tools slow to double. It's exactly the same. So now when I run it, it should take, or let's actually see how much it takes. It takes 1 second, more or less 1 second. I mean, some init time, like context switching and so on. Of course, we can't avoid this, right? So there is no magic. There's just engineering, right? When there is IO call or thread sleep, but remember, don't use thread sleep, okay? When there's IO call, which we're emulating in this example, the CPU core is not bound, right? But another virtual thread can start processing, right? So this is why this example takes only 1 second, right? Because instead of wasting time in thread sleep or like calling database or file system or something like over the network, we just use this time productively in some other thread. Right, so this is a very nice evidence why giving something back to the product and to the community, to all the users, can then just kick you nicely, right, in the future versions, because you're able to think and use it, right? And I expect more and more things in the whole JDK or Java to benefit from virtual threads and other things, right? From also other projects like Project Valhalla, for example, or Panama, right? And we'll see many more cool performance improvements. So this is it, right? Map concurrent. So now I dare to say, I really think that, okay, we won't be using streams parallel, because they are still using the same old-fashioned threads from ForkJoin pool. But because of this, because of map concurrent, we can actually use stream gatherers and therefore streams in a really nice, really performant way, right? So we can even go easily to 200. I mean, okay, I shouldn't be doing this, and it's obviously biased demo, but let me go and see how much will it take, okay? Just for the sake of having some fun. And see, it's not such a big drama, right? And of course, it also depends how much load this other system is or is able to take, right? Because I happily ended up like with 100. Maybe I should go for some rate limiting and so on. But nevertheless, it shows us that now the narrow point is not the Java, right? But it's this other system, or it's not streams, to be precise. Okay. Right. Okay. Maybe I guess we have a little bit of time, so let me go and quickly show you some a few other examples, right? A few other demos how you can use stream gatherers. So I don't know if you know this sketch from Monty Python about the dead parrot, right, from Ipswich and so on. Anyway, the concept of palindrome is that you have a word that reads the same both ways, right? From left and from right. So when you take a word and you reverse it, and it equals the reversed version, right? So how can we do something like this using stream gatherers, right? So what I'm doing, I'm working with different set of words. So this is now my stream of words, right? This is how the words look like. So I have diamond, jacket, race car. It's not even a word, just 2 words, right? Anyway, and this is my set of words. So I lowercase them all, and I run this collector, right? So I just replace all white spaces with nothing, right? And I return through. So as you can see, I can use it instead of map, right? And then I filter them, leaving only the ones there, the palindrome, and then I go again unique by length gatherer, the one we saw before, and you see that for each length I get just one palindrome, right? Even if there are many. And you see this race car. I mean, when doing the palindrome, we assume there are no white spaces. So maybe it should have been done like here in this palindrome, but it's like doesn't really matter for this demo. Then what we can see is pairs, right? So I should have this pair here, right, which is a record. Some people say, oh, in Java you don't have tuples. Well, I would say since Java 16, since we have records, we sort of have tuples, right? You just go pair, and this is the type of the first element, the second element, and so on. So I don't really see why we should have like a separate API for this. Anyway, we can do this. So what I'm trying to do, I'm just trying to pair the words. So when I have these words, right, I want to pair diamond with jacket and race card with cherry, dolphin with coffee, and so on. I didn't plan this, by the way, but it's a very nice has a very nice touch to it. Anyway, so this is what I do, right? I create an empty array list, right? And if it's empty, I just add an element, right? And I don't do anything else. And then when I have something in my accumulator, right, on current state, I just push a new pair, which is this state. I get the element from the from my state, right, from my accumulator, and this new element. So I push a pair, right, and I remove it. These new methods are from Java 21, if I'm not mistaken. So we can just call get first and remove first on your list, not just get 0, right? Yes, so this is what I told you, that it can turn elements of certain type into other type, and the number of elements is arbitrary, right? You're not limited by anything like this, right? So you can go for any number of elements. And here, my friends, what you can see is the finisher, right? The thing I mentioned, I will show you. So now it might be after I'm done processing all these words, right? After processing radar, when I'm here, I see, oops, my state is not empty, which means I have unpaired element, right? An odd element that doesn't have a pair. So I can decide what to do with it, right? I could, like, let's say, throw an exception, because let's say I didn't expect this, right? Or I can say just create an artificial element like this single stream, right? So when we run this, now we should be seeing, yeah, you see the pairs, and these are the diamond, jacket, race car, sherry, and so on. And radar is paired with single, right? Because we leave no one behind. So we add a companion here, and this is how it works. Or what we can do is these length fluctuations, for example. And this is like, again, oversimplified thing that you might use, for example, like in ops. Let's say you're looking for fluctuations. So when something is slowly going up and slowly going down, like let's say temperature, your CPU usage, like a traffic or something, it's okay, right? But when you see a sudden spike, something going instantly up or down, right? It means, for example, you're under a DDoS attack or something, or when it's going down, for example, there was like a massive failure, something in somewhere, right? And something doesn't work. So you also need to be alerted or something like this. So of course, I have to mention that you shouldn't be inventing these observability on your own. Like use something reliable, like from Elastic, for example. Wink, wink. No, seriously, this is like a good stuff anyway. But here I want to demonstrate you the purpose, right, or the idea standing behind this. So what we can do, again, I have these words, and as fluctuation, I see or I understand that this is like a difference by more than one character. Let me find something. So, for example, when I see table and train, there's no fluctuation because the length is exactly the same, right? But when I go from this rotor to deified, there are more than one character in difference of the length, right? Which means that should be picked up as a fluctuation. Okay, so I'm just creating this window sliding that will give me quite conveniently a list of 2 elements, which means I can calculate like the difference between the length of the first and the second element, because it's 2 elements, so the second is the last one. Very nice, right? And if the absolute value is greater than 1, it means I have a fluctuation, and then I want to alert the operator about this, right? For example, so let's run this demo, and yeah, as you can see, rotor and deified and even deified and level are seen as fluctuations, right? So we can use them as this thing, this see, and they very nicely like created pairs or 2 element links, or lists of elements. And I was even searching for one more like more sophisticated demo, and I came up with the idea, why not actually show you something that you can do, for example, with Elasticsearch. And let me go you and show you this. So this is a thing called Ngram tokenizer. So basically the thing is this: unlike SQL stores or relational databases which you use to store data, to keep record and so on. Of course, you use Elasticsearch when your primary focus is like search, like any kind of search, like regular search, vector search, and so on and so on. And the nice thing about Elasticsearch is that your fields can actually be of many types at the same time. And this is not done by like dynamic casting, but you actually store a value of a thing in a field, like many values for each type. And one of the types is called ngram, and it is very useful for querying languages that don't use spaces or that have long compound words like German. So imagine you have like an e-commerce store, right? You're selling car parts, and now you need to make sure that people can buy from you Scheibenwaschanlage, for example. And how you do that, you can use you remember, maybe you remember these things that you have, like you type like 2 or 3 characters, and suddenly there's like a drop down, right, showing you options that you can select in the page, right? And it's not always in the front, but also sometimes in the middle and so on. And this is where the ngram is or can be used, right? Yes, I can actually even like show you see when we go for this quick fox, this is what I get. So I get Q, then QU, and then U, then UI. So it's sort of like a sliding window, but also it has different lengths, right? And I can go for different, I mean, the default parameters are 1 and 2, but I can go for different ones. So as you can see, it's ABC, ABCD, then BCD, BCDE, sorry, here, and here we have CDE. And I should have a test that mimics just that. Let me go to the test. Yes, so of course this is like for throwing an exception, but yeah, if I have this ABCDE, I expect to have when I giving 3 and 4, I expect to have this as my result, right? So of course I'm not telling you to re-implement Elasticsearch, right? There's no need for that, I guess. Elasticsearch is HTTP license, right? It's open source again. Thankfully, and as you can see, the tests are passing, right? So the implementation of the ngram gatherer I have is it the one? Yes. So apart from like checking the invariants in the constructor, that's always a good idea, I think. Now we have these parts that come from this gatherer API, right? So I have as initializer an empty string builder, right? And what I'm doing is here's the integrator, and I have my current state, which initially is an empty string builder, right? An element I'm processing, and basically downstream somewhere like a way to push the elements downwards. So I append the element to my state. So if I'm processing this A, B, C, D, E with 3 and 4, what I'm doing here is I check if the length is of at least 3, right? It is not. So I'm not pushing it down. It's also not max gram. So I just go like return through. So basically I add A, I add B, I add C, right? And then I see that this is the length of mean gram I have, right? So I'm pushing the element ABC. Okay, and this doesn't happen, so I go for through. So here and like next element, which is D, and then I append it and I have A, B, C, D. So I push it, but then I also see, but this is my max gram length, right? The 4. So what I do, I remove the first character, which is A, and then I push downstream B, C, D. And so the story goes, right? As you can see, and here we go to one of back like to the one of the slides I was showing you. If I have like something like this, A, B, C, D, E, right? And let's even sorry, here assume I had 5 like elements. You can, or just one element, you can turn it into like any arbitrary number of elements. So I turn it into 5 characters, right? And I have something like this. So I have 5 elements. But if I had this n-gram like 3 and 3, then I would have A, B, C, B, C, D, and C, D. So that just 3 elements. So basically, the gatherers allow us to produce any number of elements at any time from the input we have. Okay, so I think that's it when it comes to demos. So I would like to ask you to always, and for everyone, every speaker, right? And at every event, be that CoffeeJUG or not, provide your feedback, how it was it okay, wasn't it okay? Because thanks to this, you will see in general better speakers, better talks. So I think it's in your own interest as well. So I would like you to provide some feedback, right? In the meantime, it's an anonymous survey, right? I don't know who you are. Just let me know what you think about the talk. And now I think it's time for questions. Should we have any? Back to the studio. Yes, nice question from Oleg. I think I answered it with this map concurrent, right? We can use virtual threads. They're used under the hood, and I think it's the coolest part of this whole API, right? So also don't get me wrong, if you have CPU bound tasks, right, or CPU, sorry, intensive, right, if you're like sort of think compute next Fibonacci number, it doesn't make sense to go virtual threads, right? But if you have lots of IO involved, right, it's especially long IO like network, it's really cool way to have it to simplify or like to get like performance improvements, right? In that case, go for virtual threads. I really don't know, Oleg, if because the question is, do you think that in the future JDK would add more built-in gatherers? I don't know. I don't work on JDK, at least not directly, so I don't know. But all of us can submit like a PR or make a proposal. So I think if you find like a legit use case, you may add it. But I also know I didn't include them in the slides, but they are already like libraries using gatherers, so you can just add something to your POM or Gradle build file, and you'll have more gatherers, just not from the JDK itself, but from the external dependency. What is the significance of the true return value in the integrator function? Okay, it basically says or means give me more elements, right? Let me just show you this example, and let me go for this. Where was it? I should have a demo for this. Where is it? Okay, here it is. See, so what I can do, for example, then it would be like a just terrible name. Then it wouldn't be unique by length gatherer anymore. But I would need to rename it and let's say call it top 3. Okay. But what I could do is this, for example, I could check instead of returning through, I can check if I already returned 3 elements, right? So if I didn't process 3 elements so far in this like in the duo example we had in the beginning, then I could say return through, which means give me more, right? But I said I can also say I already processed like 3 elements, I'm done processing here, right? So I return false, and this short circuits the stream, which means basically that I'm dropping all the other elements I won't be processing anymore, right? So this is why it's not always true, but you can also decide that you like break the processing and you go for false. What would happen if collectors to unmodifiable set were replaced with collectors to list? Question from Julia. I guess you are talking about, let me find this example here for right, for example, so instead of having a set, we'll have just a list, right? Let's go here, for example, to list, and of course I would need to call just now collection, right, to make it simpler. And now where is it called? It's not, what is it? Collectors, sorry, which one was it? With gathering up. Okay. Yeah. So I like these talks, which are not like conference talks, because we have more time to run the thing. So visually, as you can see, there is no difference in this code, right? Because I'm just printing it like this, but we can go and say unique length words, and then south. If I print everything together, you can see that it's just a list now, not a set, right? And that's it. So in theory, now the order matters. So it's just like a difference between set and list. I, by the way, would recommend going for to unmodifiable list, because then, I mean, if you can't modify it, it's usually like, you know, less bugs involved. I listened to you, so not have particular question, but like, okay. Thank you very much. Thank you very much, Max, as well. I really hope it was useful. My general intent behind this talk, or for this talk, is that I try to show you folks that there are nice features and nice performance improvements to Java, right? And it's really worth it to basically bump the version you're using, both for source and both for runtime.
Agree. Thank you, Piotr. Thank you. Hope you learn. See you later. Thank you for joining.